Not sure how the audio volume is going to be on this because another project I've got working, which is the subject of this video, but just an update from the last video. I built that AC motor tester switch, and I went ahead and updated the cord that I use to test motors. I put heat shrink on each individual lead, cut the ground off because even though the ground pin's broken, I never used the ground before anyway. And then just put one big piece of heat shrink over both pieces and updated the female spade connectors that were on here. This will only be light duty, so these plastic connectors shouldn't melt or deform or anything like that. The reason why the audio wouldn't be all that great on this video is because I've decided, and probably regrettably, to modify my Rode VideoMic Pro. I wanted to add the ability to power it off of a wall adapter. So I bought this wall adapter from Tanner Electronics, and then this female plug, which is what I'm going to use to solder to the control board here. So I took it apart, which it's just one screw to do. You have to take the two switch plates off, and then maybe one other thing. No, just the two switch plates off, and then the screw at the bottom. And at the same time, these shock mount rubber bands come out the back. So this could be a little weird to put back together, and hopefully it doesn't turn into a complete disaster. But I figure I'll solder these leads onto the control board and drill a hole out of the back of the case and see how it works. If it doesn't, worst case scenario, I don't use it. I doubt that it would pick up any additional noise or anything and make the microphone susceptible to hums or anything like that. But it very well could. This wire could just act as a big antenna and get onto the power source and possibly cause some noise. The suggestion has been made that just doing this in general is going to add enough noise to where it's not going to be desirable. So we'll see. So first we'll start with a power adapter and make sure that we've got enough power. This is a 9-volt DC power supply, has a 1 amp current capability. First thing I want to do is hook this up and first of all confirm that the center pin is hot. Second thing I want to do is see what the voltage, the standing voltage without a load is. And then I want to put a couple different loads on it and see what the voltage drop is. We'll plug this into an outlet and confirm the polarity. All right, that's not that surprising that without a load, it's showing a higher voltage than what it's rated at. So let's put a load on it. I'm going to start out with two 10-ohm resistors in series. I've got these set out for another project that I was going to build. But I'll just go ahead and use this as a load. Try to keep those separate so they don't short out on each other. So there's a 20 ohm load, and voltage is dropping down to 10 volts, which is probably what we would want to see. Maybe it might be a little bit high. I don't know what the current draw on the Rode VideoMic Pro is. I would imagine it's 0.5 amp or so. So this is probably a realistic load for it. And I don't think running at that high of voltage is going to be that big of a problem. Now, out of curiosity, I'd like to see what just a 10 ohm load looks like. So there's a 900 milliamp most likely current draw, and it dropped down to probably 9 volts. So I'm happy with that. Alright, I guess the first test is going to be to power it up and see what happens. At first, I couldn't figure out what was going on. As soon as I would test the circuit board for voltage, it would immediately drop. When I tested my wall wart power supply, it tested just like it did at first, 13 volts DC. I double checked the continuity in the plug that I'd soldered to the power terminals, and everything was good. This is when I started to get nervous because I thought that I may have soldered across the power terminal and some other circuit in the circuit board, causing the current draw to spike and pulling down the voltage. I think I fried my power supply. So I used my bench power supply, put it at 9.6 volts DC, and decided to plug it into the mic and see what I got. All right, it seems like it works, but I got to figure out what happened to my power supply. I think I know what happened is I shorted it out. When I was doing that resistance test or whatever. So anyways, all right, now I put this thing back together. Well, that didn't turn out too good. I don't think I planned my spacing all that well. All right, so I'm going to trim a little bit of that off right there. That's what the finished product looks like. I don't know. I wish I had some more strain relief. Maybe I'll put a zip tie to hold it to the chassis right there. It's probably a good idea. So now that we got that, it looks like it came back together okay. Where the audio wire comes in, looks like that's seated okay. And then where these two shock mount pieces of rubber come in, looks like that's okay. I think there was always this little gap right here, but it's hard to say. But it looks like it fits together okay. And here's really what the main part of this was. That first initial cut right there where I was plunging in it like that didn't need to happen. I don't know what I was thinking, but I just made a mistake. But anyways, it doesn't look all that bad. And then I'll probably end up putting some kind of zip tie or some kind of strain relief for the cord right there. So let's power it on. All right. And I guess what I'll do now is I'll switch over to the microphone and see what it sounds like. Check 1 2, test 1 2. Check 1 2, test 1 2. This is a test of the Rode VideoMic Pro powered by 9.6 volt power supply. The microphone is plugged directly into a Canon HF S20 via an 1/8 inch extension cord. This is the Rode VideoMic Pro plugged into a 9.6 volt DC power supply. It is currently drawing 100 milliamps. The Video Pro is connected and set at the same height and angle that it would typically be when I'm doing my videos. This concludes the test. Well, not really. I've got some other stuff I've got to do. But just judging by the decibel, you can't really see that. I'll see if I can get it on my phone. So this is what I'm looking at when I am doing projects here on the bench. I look at the monitor directly in front of me, which I have hooked up through an HDMI cable. It goes directly from the Canon HFS 20 down through a mini HDMI to HDMI, and then this particular monitor, this LG monitor that you're seeing on this camera. It has a DVI in. It doesn't have HDMI in. So I have just an HDMI to DVI extension, a little 6-foot cord that takes it from HDMI to DVI, and I don't believe there's any signal loss there. What I'm looking at is to make sure that I'm in the center of the shot, of course, when I'm zooming in and zooming out, so making sure that you can see what I'm actually doing. The second thing that I'm looking for is to make sure that my microphone is actually turned on and it's getting a good level. Now, I have come up with this setup. It seems to be the best that I have figured out. On the HFS 20, you'll see that I've got my microphone level set to 9, which I guess is the input gain. It probably goes up from 1 to 20. So one thing that I'm looking at is to making sure that I'm not peaking, and I'm making sure that I don't hear any noise. And typically above that minus 40 dB is when I start to hear some kind of background noise in the microphone. And it could be because I have it placed too close to my heater, or could be too close to the oscilloscope or something like that that creates noise. The biggest thing that I fight here in my office is the 60 cycle hum from the fluorescent lights that I've got. and that'll get addressed this year. I'll probably switch everything over to LED. That's what it looks like when I'm on the bench, and I just want to make sure that I've got a hot signal. That's pretty much it, and that there's no noise. Right now, it's not a fair A/B comparison because we don't have it powered from the battery and then powered from the wall. It happens to be powered by the bench power supply that I have. It's an X-Tech 382213, which is basically just a DC regulated power supply. And I've got it set at 9.6 volts DC, and it seems to be drawing 10 milliamps. I could probably just do it right here just for a rough test. But what I want to do is record a minute of silence being powered by the microphone. Yeah, I can do it right now. There's no reason why I can't do it right now. So what we're going to do is we're going to record a minute of silence, and we probably don't need that long, but I may have to edit a couple of things out if I move my chair or something like that. I don't want that to make the test funky. So this is obviously not a scientific test. This is obviously not looking at it on an oscilloscope. This is not anything like that. I just want to see if there's an audible difference on my studio monitors once I get it in Sony Vegas and see what it sounds like. So let's do a minute of being powered directly from the power supply, and then we'll do a minute of the battery and see what we come up with. I just wanted to see what the voltage was on the power supply. All right, 958. Now we're going to lose audio for a second, and I'll power it directly from the battery. I think we got a battery that's close enough. Once it's under a load, it's probably going to be that, and we'll be able to test that out. Okay, so it shows 9.4. So I think we're fine. I'm sure that the power is regulated inside the microphone, so it probably will operate down to just below 9 volts anyways. Who knows? There may be some noticeable difference right now. Right now it's being powered by the battery, and it looks like there was about a 200 milliamp current voltage drop. So let's see what a minute of silence seems like with the battery. So I think it's fair to say that there's not a noticeable difference between being powered by an external power supply and a 9-volt battery. Here's a shot of the Rode VideoMic Pro next to my GrooveTube's GT55 condenser microphone. I thought it would be an interesting comparison to see what the floor noise was between the two, but the floor noise on the GrooveTube was almost identical to the Rode VideoMic Pro, so I abandoned the idea of comparing the two. But I did want to do one more test before I concluded that there's not that much of a difference between powering the Rode VideoMic Pro on a 9-volt battery or a 9-volt power supply. So I connected the Rode mic into my Focusrite audio interface. I set it up in SoundForge to record a stereo file at 24-bit 96K. And the conclusion was that the floor noise is basically the same. Here's the results. This is the Rode VideoMic Pro powered by a DC regulated power supply. This is the Rode VideoMic Pro powered by a 9-volt battery. Don't forget to like and subscribe.
and that's pretty much what it looks like. Sorry, it'll probably cast a shadow over it, but I'll do a review on how I got this set up sometime in the future if anybody's interested in it. But so that's some of the meters that we're going to put in this bag.